Yeah, I'm going to be talking about event sourcing. It's not a project I actually did with online. It's something I do in my spare time for bowling. Adam came up with this nice little quote. Your applications together, spare yourself, and create and strike out using event sourcing. Come on, don't be a turkey. And for those who don't know, a turkey is 3 strikes in a row. So, the problem. Going back to 2006, we were hosting the Master Bowlers Association of Canada National Tournaments. Now, this tournament has about 200 competitors across 5 divisions, including singles teams. And we're not talking about an application to control the games. It's an application to actually track the tournament. So all the final scores that are bowled, what the standings are, how people ranked, as well as all the lead up for the host committee. They have to get averages, names, demographics on people, what the room assignments are, what the travel information is, so they can pick them up from the hotel, practice schedules, a lot of information. And it's been actually my last couple months helping them with this. So in the past, they'd always just uploaded PDFs at the end of the day, which if you're trying to follow a tournament from another province, you know, your kid's bowling or something, really annoying because they bowled 7 games and you don't know what any of the scores are until 10 at night, like 4 hours after bowling finished. So it wasn't a great experience for people who are trying to view it. So when we hosted, I wanted a way so that kind of on a game-by-game basis, people knew exactly how everyone was doing and could keep track. So I went out of the way to build this app. And there's, as I was saying, there's a lot of stuff. There's 8 provinces, 5 teams from each province, 5 people per team, plus the coach, 5 singles divisions. They bowl 21 games over 4 days, which results in over 5,000 games of bowling that have to be tabulated, correlated, standings, calculated, averages, wins, losses, and all the information the host committee needs, like where it is, what the bowling centers are, what the lane draw is. You have to know what lane you have to go to next to your bowling, whether you're home or away. So tons of information they have to get. Once this got moved to event sourcing, it results in about 13,000 transactions in the system to track all of this. So what's that look like on the website? So a single game has the 2 provinces, what lane they're on, who the bowlers were, what their score is, whether they beat their average and by how much, and whether they won their points. So in this one, Manitoba did well. We got 6 points to Quebec's 2. Woo! So you can look at a team's results. So what was their win-loss record? Manitoba didn't get off to a great start in that one, but they started winning later, and it goes down to 21 games. But this is a roll-up of about 100 different matches to be able to figure this out. And again, it has all the lane draw and what your opponent scored. The standings for one division, which there are 5 plus 5 singles competitions, has a lot of information. So this won't mean a lot to everybody else, but I see what the scores are, what their plus minus is, who they're playing, their wins, losses, basically a matrix. And in the end, what the standings are on the far left, their final points. That's rolling up roughly 1,000 individual games to get all that information. So there's a lot of calculations. And if you have to do this report on the fly, it takes a while to generate, and your host isn't happy. So we were using a budget host, like the $10, $15 a month host. They shut us down. Twice. The second time was at the worst possible time this could have happened. The tournament was done. Everyone was done bowling. They were going off to the banquet. We were trying to print out the final standings. And we couldn't access the website to get these. We had to get on the phone and beg to get access to the database so I could run it locally and thankfully print everything out. So that was scary. And the next time this happened, or the next time we hosted, I did not want this to happen. So I had to think, how am I going to do this next time? So let's look at how we design apps now, which is similar to how this one was designed. We're taking it and we're thinking, I'm not going to make the same mistakes I made last time. This time, I'm going to get all the layers right, all my domain stuff right. Data access layer is going to be clean. It's going to be beautiful. You have this vision, and you're thinking and you're studying. You got all your plans. You get to work, and what happens? Time passes. Requirements change. Your team changes. The domain changes. The market changes. But you're making all these changes to the application as you get more information, and you see your app, and you have no idea what just happened because you just created this. The foundation is suspect. There's wires dangling out. Somebody just looks like it just ripped off half the house, and there's a door on the second floor going nowhere. I know our apps look like this more than we'd like to admit. So why did this happen? Well, as I said, everything's changing, and it's very difficult to support that. So our standard structure, we have a very normalized database. Smart, we build repositories over top of it. We translate the data into our domain object, so it's not necessarily the same as our database. Then we have our service API where all of our business logic exists, and we have DTOs to map between the clients. So you have these nice separations of concerns. The problem is there's reads and writes going both directions through this system. So no thing is really optimized to do reads or to writes. So it's kind of like a road where, yeah, you can get across, but if there's more traffic in one direction, you end up with bottlenecks. And it's not ideal. So while it works, and it does work well, it doesn't support either thing well. It doesn't support reads very well, and it doesn't support vice versa. So I'm not trying to say that the way we do it doesn't work. I'm not trying to say it's bad. I'm saying there's another way if the cost of reads and computation is what's killing your application. Because that's what shut us down was when everybody was loading those reports, we were absolutely killing our shared hosts, and all their other customers were complaining that their sites were slow and it was our fault. And in the middle of a term, we couldn't upgrade to a dedicated server, and that would have cost, I don't know, in 2006, like $100 a month as opposed to 10, and we couldn't migrate in the middle. So I'm not saying this replaces everything, it's just another way to design an application. So as I was saying, it's trade-offs. Models that we were using, our DTOs and our domain layer, are used for reading and writing. When you're just updating a name and you got to pull back an entire record, it seems kind of wasteful to just change that one value and then save it again. And we've lost context about why that changed. So if you're changing a name, there's many reasons. It could just be a typo. Great, just change it, save it. We don't really care. But if it was, for example, they got married and they're changing their last name, other systems might care about that, so you know to update benefits and insurance policies and get all those things in sync. But you need a way to differentiate the two. So if your system tracks why you changed the name, you can have other systems hook into that. We can't look into the past. Similar to you can't know why you changed it. I don't know what the value was 3 days ago unless I had an audit log, which is another thing we've bolted onto our house. And scaling can be tricky. If everything's doing reads and writes, and if we agree, which I kind of hope we do, 80% of an application is usually reading. We write data once, but people are reading a lot more often than they're writing. But we kind of treat them equally. In fact, we treat our databases and we optimize them for writes. We don't duplicate data, which means when we read, we're doing a lot of joins to get all that data together, which is a costly operation. We're doing that every time we read. There are ways to mitigate that by writing denormalized tables, but then you gotta make sure you keep that all in sync. So these are the problems I faced as I was thinking about how I was gonna build this new app. And we do this a lot. Between layers, we're switching between our DTO or domain, and we're just going name equals name, address equals address, gender equals gender. It's quick, but if we're in the cloud, those are compute cycles we're paying for, and they're providing no real value. If we're changing our database, we're probably changing that all the way through all our layers anyways, so was it really worth it to add that? I don't know, maybe, maybe not. So, as I was saying, going back to those few trade-offs, our apps are a snapshot. It's like looking at one scene of a movie. We don't know why they got there. The person's falling. Well, were they tripped, or did they jump, or you don't know. You just see the current state. So we've lost context. So we need a way to do that, and we could add logging and auditing, but it's just a bolt-on. It's not core to our system, and it only goes moving forwards. So we've added logging, great, we've logged everything in the future, but I still don't know what happened before that date. The business might ask questions about that. Why did that change? Well, I don't know. How many people put stuff in their cart and then abandoned it? Well, I can start logging it now, but I can't tell you anything before. So it's nice to have a way to see into the past about questions we didn't know the business was going to have. It takes a lot of analysis to think of those things up front, and then we build things we don't need. your denormalized database probably doesn't reflect any of these things. As I mentioned, scaling. If your app is at its limit, you can throw more hardware at it to a point, and then you have a bottleneck because you have too many users. Well, maybe you add some caching or clustering or something at the front. That could work, or your database is getting hit too hard. Well, you can start scaling out. Now you got to start mapping stuff back and forth and migrating data. And when writes happen in each system, you start with contention, and there's drawbacks, and it's difficult to control that. What else do I got? Sorry. So if we want to scale those systems, we usually have to re-architect it. Maybe we just pull a piece out that we can scale, but it takes a lot of work to do that and rip it apart. As I said, reading is more important than writing. Most studies show that it's about 10 to 1 in your average application, 10 reads to 1 write. So we should maybe design our apps to be more friendly to reading. People are willing to wait for a write. If you click save and it happens instantaneously, you sometimes wonder if did it actually save? So people are willing to wait for that. So it's okay if writes take a tiny bit longer, but we really want reads to be fast. People don't like waiting for data. And we do this in other industries. You don't write a book once and then get 10 people to read it, the same copy at the same time, but our applications are used like that. So having multiple copies of data for people to read quickly is a good thing. It scales better. I've already said all those things. So just to sum up, reading versus writing are different things, so let's treat them like different things. Let's build a system that captures why stuff changed, which in my case was useful as I have users from across Canada entering their contingents that are going to nationals, asking me, why isn't this working? It's nice to be able to see what they actually did, not just the current state of things. I can look and see why it got to a certain state. I can scale it a little bit easier, which I haven't needed to do. And again, most importantly, reads aren't the same as writes. The solution I came up with, well, I didn't come up with it. It's an old solution, and other people have been doing this. Accounting does it. We keep a ledger. The bank doesn't store how much money is in your account as the source of truth. It stores all the credits and debits that happen to your account. If they just stored that number, anybody could change it and write up millionaire, and they don't know why it's right or why it's wrong, which would be awesome. So if you have a ledger of all your accounts and everything that's happened in them, you can actually generate any other accounting report you want, no matter what. You could lose your balance sheet and recreate it from your ledger. You could lose your accounts payable and recreate it from this. Those things are just views into this data. So let's define some terms. Commands and events are the messages that flow through your system. Commands, they're a request. So I could ask Dawson, can you give me $20? Doesn't mean I have $20. He can say no. Or, can you give me $20? No, didn't think so. That's the difference between events. That event happened, he said no, I didn't get the money. If I got the money, that would be $20. I'd store that as an event, which is why it's different than a command, and why we don't actually store commands in our system. We store the results in the event. We have command handlers, which are the business logic, similar to how Dawson was in that instance, that will decide if that command succeeds or fails and what the resulting events of that are. Aggregates, these are your entities, basically a record in a table in a regular normalized database. So a person like Dawson, you would be an aggregate. I don't know why I'm picking on you. And then you have your read models, which are the different views into your data. These will be generated from events and be your denormalized data that is what you want to show to your user, exposed from your API, show on a screen. Data will be duplicating these things. They'll subscribe to multiple events, but we'll talk about that more. In my app, things like high scores, standings, individual results, those are my different read models. If we look at this picture, somebody issued a command to fire this. These people here would be your command handlers. They decide if this happens or not and how it happens. They obviously decided this was a lawful order and they fired the guy, or how is it, whatever. The resulting event is it fired, the projectile's moving. There's probably more events that are about to happen downfield. What was the other thing? Your read model would be people like their commander. What was the result of this? I need to know that information. Maybe depending, your enemy might be actually looking at these events of what happened. Like, oh, you blew up our building. And that's where the differences are. Everything has these different aspects to it, whether it's computers or not. It's just differentiating your command handlers from your events, from your read models. So what we're going to do is take our regular system and split it apart to a read side and a write side. Our write side will take commands and issue events. Our read side will consume these events and generate the data that we actually want in the format we want it in. Everybody cool? Not going too quick. Awesome. I feel like some slides got missed here. So what do we need to build this system? We need command handlers, as I said. We need event handlers, which will generate our read models. We need a place to store these events. This is our truth. These are our facts. We need event handlers to read these events and generate our read models, which we need a place to store these. And we need orchestration to tie all this together and handle passaging our messages around and making sure things flow through our system the way we intend. The neat thing about the read models, because the event log is our source of truth, I can delete them. Don't need them. I can generate them at any time. In my bowling app, I run through 35,000 events in 17 seconds and regenerate 15 read models in 17 seconds. I think I said that. And this is on like the base Azure D1 shared tier, like one step above free. So it's not a dedicated server, it's not multi-core, but it handles those 35,000 events into 15 different states or read models in 17 seconds. I've also rewritten how I do storage for my read models 3 times. The first one was some proprietary format that just kept breaking, wasn't reliable. So I deleted it, rewrote it, ran all my events through, and pushed them into Azure Table Storage. It was great, but it was a little bit slow. So I rewrote how my read models store data again, and I put them into blob storage, and they just serialize themselves and save. So I'm able to change my persistence layer of the data that I read from quite easily and quickly. So the right side of our application will look like this. We'll have our clients, we'll issue a command, and our command service will decide what it's going to do. Is it going to issue some events to everything that's listening and store those events because they happened? Is it going to issue more commands like, say, email? You don't want to be able to run an event and have emails just keep happening when you replay these things and regenerate your read models. So you have to differentiate the two. And how this works in our app is it pretty much maps one-to-one. This is how we enter a score. What position was the bowler in? What was their score? Enter all 10 of them and hit next. And it generates a simple C# class that has your bowlers with their scores and their position. That's it. Home, away, and what matches was. There's really nothing there. And events come out. This match was completed. It was the seniors division. Manitoba versus Saskatchewan. There's actually about 15 events, but one of the games was Russell Knight bowled 243. Great. Those things happened. Our system knows they happened. There were no errors in the command handler. Perfect. The read models will then read these. But these events come into our event handlers. They generate our read models, which is our persisted view of this data, how we want to represent it. And an event can go to multiple read models. Lots of things we'll care about if a name changes or a score is entered. And on the client side, there's a simple thin query service that they talk to that just grabs that data that's already been collated and displays it. So when I ask for standings, they've already been generated in the format I want. All the data, all it is grab that data, display it on the web page, I'm done. It's extremely fast as opposed to being a couple seconds to generate that page like it would be in a traditional system. Putting it together, you have the way event sourcing works. Different than our layered approach, stuff just flows in a circle, over and over, gets to the client to make decisions, issue commands, we handle them, spit out events and store them, our event handlers generate read models, and they go back to the query, and then the user can read that data, go on and on and on. So it's not data bouncing back and forth in your system, it's just a cycle. Any questions so far? No. So Einstein said, everything should be made as simple as possible, but not simpler. It's a great quote, and that's what each of our components does. It doesn't read and write, it does one very specific thing. That read model just looks for scores, just looks to see if they're high score worthy, and saves that. It ignores everything else. It also listens for the name, so it knows who it was. It's not writing data except for its own version of truth. It's not making any decisions about that data. It's just displaying it. The problem here is that's not what Einstein said. He actually said this much more complicated thing. There's, you know, you guys can read. But I think it's kind of funny that his quote was simplified, and his quote was about simplification. Yeah. So I thought that was quite funny that he was trying to say make things simple in a very complicated way, which is what we do in a lot of our apps. We try and make them simple, and we end up overcomplicating things and over-architecting them. But let's not do that. So let's look at some code and what each of these components actually looks like in a system. So we're going to follow one little bit of data through our app. Saving results, which I showed you the screen earlier. Going to our command service, which will return an event that the match was saved, and we'll store that event so that a few of our read models, like high scores and standings, can use it, generate their view of that data, and that can be queried by our clients and shown on the screen. The box on the right side of the screen are our UI, the score entry, the high score screen, and the standing screen. The top left is where we store our events. That is the most important part of our application, is our events. That is our database. Our bottom left here, generate our read model and our persistence of those read models, our views of data. We can delete those, we can lose those, doesn't matter. So, as I said, we're starting with command. Enter their scores, it issues a command, goes through our command service, and it gets to our command handler for scores. Now, the purpose of a command handler is to grab your aggregate, which would be that match or the score, load all the events that have happened before on it to get its current state, because they don't read from the read models, and then try and issue that command. It might complain, hey, you've already entered this game before, but thankfully this hasn't happened here. And our command handler says, oh, the game's completed, this is its participant score. Whoever cares, do what you will with this data, but this action is valid and it happens. That's where your business logic lies. Storing a score isn't really a lot of business logic, but the code for this is quite simple. Handle some commands like saving a match result, saving a match, creating a couple other types, and the aggregates they act upon. So the match aggregate. This first line in our handle function takes in our command and a function that loads our aggregate. All it does is gets the ID, grabs all the events, loads it. This happens amazingly fast because you're grabbing like 10 records and saying process these. And you now have your aggregate. This is your match in its current state. In this case, it probably doesn't have any scores as part of it. I do my business logic to determine what I need to do. What events come out of this? Sometimes I might only return 1 or 2 events if it was a singles match. Other times I'm returning events for every bowler on the team. I got to calculate their pins over average with that. Pins over average, there's 2 divisions. One is just straight up your score. The other is kind of like a handicap in golf. It's based on how you normally perform and how much better or worse you are than that, and that's what POA is. So I calculate that and add that to their result. The events like before, the match was completed between these teams, and the person's score, amongst others. The event is then stored in our database. And you might be wondering what the database of events and aggregates look like. It's extremely complicated. That is my entire database aside from about 3 tables of security information. The aggregate and its type, so match and a GUID that identifies it as a record. all the events that have happened to it that the command handler has returned. So it was created, scores were recorded against it, it was completed. It's kind of nice when you never have to look at the database again because there's only 2 tables and you don't think about it, you just write code. So these events are then passed off to the things that generate our read models. These could handle multiple events. I'm only showing one here. 2 events can handle one to each of them. They would be all the data that you used to join together, you're just listening for now. And as it comes in, you're collating and updating your view of the world, of what the high scores are, of what the current standings are. It looks very similar to your command handler. It has a handle method, and it gets the event. In this case, there's a bit of code because the first year I didn't have the year on it. I had to add it, so I default to 2014 if it's missing, which is kind of nice. That the event didn't need data, I just deserialize it. We are loading up the current division, removing this match that had already been entered. I let people correct stuff. And if the score was above 275 or their POA, kind of the difference on how well they normally bowl is over 75, I carry on. Otherwise, I don't care about this event. Their score wasn't high enough. Who cares? It's not a high score. And then I add the score to my list of high scores. Their name, the match they did it in, what their score was. And that's my high score read model. Now it has to get saved though. It has a representation internally of what all the high scores are. But how do I save it? I serialize it and write it to a blob. There's really nothing else to it. It's basically a document store. This is going to an Azure thing, Azure blob storage. I don't like to remember that. But basically, it calls its save method on the read model. And the read model just goes, serialize my JSON, put me in the database. I'm good till you need me again. Excuse me. This happens after every single event. I thought this would actually be kind of slow, but it's not. Even if I were to run through all those events and save each time, I mean, it took about 2 minutes to run those 35,000 events, but that's if I save each time. I now don't do that. I only save at the end of a whole stream when I'm rebuilding. I'm spotting it at 17 seconds, but it's still amazingly fast, and I don't even notice this happening in the application. Oh, my save method. Grab the blob container, serialize, upload the text, and I'm done. Loading it is pretty much the reverse. Find a blob, deserialize, return it, and I'm done. The data access for your read models is whatever you want it to be. I use blob storage to serialize it. The query service to read these is uses those security tables I talked about before in my database, just to make sure people have access to this. Some of the personal information only the host committee gets access to. But there's 3 of them on the page. They go to the read model and say, give me this information you already know about. That's it. So retrieval of data is instantaneous. And the high scores that we were just going through and building show up on the screen. The second the page loads, there's really no wait time other than one API call and a quick call to deserialize the blob. But I don't have to do any table joins, whereas before I would have to look at 5,000 games and sort them and determine and calculate the POA and determine which ones are high or low. I guess you could do these things as you're writing in a regular denormalized database and have a copy of normalized tables, but then you have to make sure those are in sync. And if they get out of sync, how do you fix that? Which one's right? The one that was written to the denormalized view or the one that was written to your normal view? And if you're making decisions because you showed the user the denormalized view and it's wrong, then repassing invalid data in is going to be confused. And you'll have interesting things to debug, and you still won't know why they happened because you have no history. I haven't talked about how the orchestration happens. You could use a service bus or not, but then you're adding complexity that you don't necessarily need. And most talks about event sourcing talk about pushing stuff up to a bus like Azure and Service Bus, and then you have to worry about, well, did it actually get there and will it actually get passed down? I'm doing everything synchronously right now. I don't need to add the delay or the complexity of asynchronous calls and not knowing if they succeeded or failed. So I'm not using Azure Service Bus. I'm not using NService Bus. I'm just using a simple custom written thing that on startup, we use some reflection. And anything that implements I handle commands, we add a handler for it. I subscribe to, we add a subscriber for it. And that class is just a collection of functions. So I subscribe to save match command, this command. Yes. A command can only have one handler. This is right, so you don't want contention. So if there's one registered already, I'm going to fail, which better not happen because I'm writing this code. And then I add it. And what my command handler does is sets up the function to rehydrate my aggregate from events, invoke the command on itself, like on the aggregate, so save the match, stores the events to the event store, and then publishes all those events to the things that subscribed. And the subscribing, oh, I don't have a slide for that. The subscribe for the events looks basically like this, only it doesn't have to publish events at the end. Otherwise, it's pretty much the same thing. The reflection just tells it to, this is your subscriber, and it's just a list in memory. So I can wait for these things to happen. I don't have to worry about publishing to a service bus. So that's our whole system. Everything does one thing and has a simple purpose. Nothing is trying to read and write data. It's not trying to translate data that you're updating a score and you have to load up a whole user or bowler, just update his score. You're just passing that command. It handles it, returns an event, and the things that care about it, that want to add it to that user, do that. So it's a very event-based system, but you don't need to add the complexity of queuing and taking stuff out of sync and waiting for eventual consistency. I don't have any of that, so it runs the same as a standard app, just it flows different. Aaron said to put spinning from Rick and Morty. So, so the little robot, if you've seen the show, is built, he's sentient. He goes to Rick, what is my purpose? It's like, you pass the butter. He's like, no, but what is my purpose? You pass the butter. And then he just sighs and he says, oh God, because that's all he has to do. Well, if our services were sentient, this might be cruel, but our services are great. They do almost nothing, but they do it really well. So, I don't know, I thought that was funny. So, debugging. That's an extermination tent for people like Aaron who didn't know what that was.
There wasn't a label on it the last time.
I changed the picture. Yeah, it says terminate on there. So, as I said, I have users across the country who are using this from time zones in Newfoundland to BC. So I'm not always available to answer their questions in real time, to walk them through stuff. So by using this and having an event stream of all the things that have happened in my system, when they call up the problem, I can just go look at that event log and be like, well, no, you didn't do what you said you did. You actually entered data like this, and it's right here, and then you changed it, and that's why it's wrong. I'm politer about it, but that's basically it. And then if I have a problem in production that I can't necessarily debug there, it's maybe one of my read models is generating incorrectly, I can pull these events down and generate the read models on my machine with production data, because all the information is in those read models. There's nothing I need externally. So I run it locally, and I'm like, oh, that's what it did wrong. Fix the code, publish it, hit rebuild all read models, and 17 seconds later, all the views are fixed, which is pretty awesome. I've had to do it like during the tournament, and I'm scared every time I push that rebuild all button. But in 30 seconds, it worked. It's great. So you don't have to guess the state of your system, because you can see it in your events, and you can see it in your read models. It's easier to differentiate whether somebody had bad data entry, because you can look at the events, or if it was a bad calculation, because you can look at your read models and how they use that data. So it makes debugging a lot simpler when you have that context and that why. So to wrap up, the disadvantages are, Adam asked this question when I did a dry run. What do you do when your events change and you need different versions? There's several ways. I just have been lucky that my domain doesn't change very often. And if I do have to modify them, I'm able to massage the old data into the new format without it being so drastic that I can't come up with the same defaults for new fields. But there are ways of taking snapshots of data. So you rebuild to a point, take a snapshot of your state, and you never have to look at those events in the past. So if you do have a lot of events that's taking a long time, taking snapshots throughout, meaning you only have to build from that point on now. You can always rebuild it all if you want, but you don't have to. Similar to large aggregates, you can take a snapshot of it. But usually aggregates are amazingly small. Like how many times do you actually update a person's record or an order? Like a couple hundred times tops, maybe. That's trivial to pull back those records and run it through the system. It happens like in a blink of an eye. Messaging can be complex once you scale. So if you start moving your read models into different services so that you're using a service bus to orchestrate all this stuff, that can be a complication. And it's a trade-off, as I said. So instead of having consistency, you do have eventual consistency, but it's usually not a problem. But it is a new concern, but it's a trade-off for having reliable events. I kind of talked about both of those bottom two at the same time. Oh, wrong way.
See what you did there.
So the advantage is it's a historical account. You can view state at any point in time. So if somebody comes to you and says, well, what did this look like at this time? I could just pull those events down, run them up to a point in time, stop, and view all the data at exactly that point in time. The rest of the events I don't run yet, but I can see exactly what our financial situation was on July 14th, 2016 at 4 o'clock, which I think is awesome. Your read is optimized to be extremely fast. There's no joins, which is a CREB data we've already collated. Your writes are optimized to be correct because there's very little contention. Commands succeed or fail, and your events are your truth. And scaling is easier because you can just scale the parts of the application that you need to because everything is self-contained and only cares about its inputs and outputs. There's not a lot of crosstalk. So what would I do differently? The aggregates in my system don't do much because my system is mostly CRUD other than the reporting. So I don't have to worry much about events or commands failing. So I don't do a lot of validation. Plus I have total control over the system. So people aren't entering cards. And my aggregates aren't right. So I have this thing that lets me look at the read models from my aggregates for some information, which isn't ideal. I should probably listen to Dawson's talk again so I can design these better and get rid of that problem. And that was the command queries that I'm sharing this data through. And my testing is absent also because of that aggregate problem, because I need the read model to do the testing, and that makes it difficult. But testing is relatively simple. If you have a list of events, send them to, like, just make up your events if you want to test this series, run them through an event read model. Is your output right? Yes or no? And it's pretty awesome. It actually looks really nice because you can just read what you have. It's almost descriptive about what's going to happen in the system, and you can look at your output and see if it's right. Same with your aggregates. What I got right, didn't use eventual consistency, didn't need it, I just did stuff synchronously. I have no message bus that's external to the system, so again, it's synchronous and I'm not dealing with that problem. I can rebuild my read models, which I've done an amazing number of times. As I mentioned, I've changed the layer behind them and how I store them 3 times. I've rebuilt them hundreds of times as I made changes to how I do calculations. It's so awesome when you make changes. It's like, oh, I screwed up. Fix it, hit it again, and your data is correct. But you still have your source of truth that you never modify, your event store. Basically, using event sourcing made my life a lot easier over the last time because I'm able to scale it. It runs on a $10 a month Azure instance, which I can probably get down if I don't pay for the database. Like SQL Server is kind of expensive for 2 tables. I could probably switch to something else that was cheaper. So that's awesome instead of having to buy a dedicated server the way I was doing it before. In the future, I want to play with snapshots, fix my aggregates, use Azure Service Bus so that I can actually put in some microservices and maybe do some of them functionally with F# and moving that event store to SQL and try some of these things that, yeah, I don't really need them, but I can practice them and learn. So, anybody wants to look at the code for this, and I'm more than willing to walk through it and explain how stuff works. It's on my GitHub, GitHub CAFE MBAC Nationals. And questions? I'm going to assume I did a really good job if nobody asks.
So Brad said, thank you.
Okay. I can just send you that, Dawson.
Yeah, remember to ask.
Yeah, I wouldn't want to talk to me either.
So Brad says, I'm curious about hydrating event state before adding new events and the impact of scaling and how to avoid contention for resources.
That was a lot of questions.
Do you want me to read the first part again?
Sure.
Brad, you can hear us chatting, right? So I'm curious about hydrating event state before adding new events. Hydrating event state.
So your events state, you don't have to hydrate. It's already there. You just deserialize it. It's already, they've already all been applied up to that point. It's only your aggregates that you reapply events to each time.
Because the remodel.
Because the remodel's already been persisted at current state.
Okay.
So you're just loading it, processing that one event, and resaving it with that event now applied.
Okay. And
Yeah,
then
maybe the
second,
terminology is wrong.
The first part. The second thing is about the impact of scaling and how to avoid contention for resources.
I don't really know which contention for resources he's referring to.
So, Brad, I'm going to make some assumptions until you provide additional content, but it might be you still end up with a read. You could still end up with contention against the read model if scale increases to a large enough number.
So with your read model, it's very easy
Concurrent
to
users.
have 10 copies of your, let's go back one. Say high scores. Everybody's looking to want to see what the high score was, and you couldn't keep up. You could make 10 copies of that service and that read model generation and have them all subscribe to that same event, so that when users are coming in, well, one goes to this version of it, one goes to this other version. But it doesn't become a problem as fast because there's no CPU cycles to generate it once it's already generated. You're just displaying it. So you can actually go a lot further before you have to scale. And it's because you can have multiple copies of this, it's really easy to scale. They might not be 100% in sync all the time, but if you print something out and hand it to somebody, it's out of sync immediately anyways. So just because Tyler went to the one page and saw, you know, the high gain was 400, and somebody else saw 398, in a few seconds they will be in sync, and it's not that big of a deal.
So in this particular case, he says, first thing about curious about, so he's talking about, he says, I'm not talking about the read model, he's talking about aggregate events. And the supposition he's making is you have to read the full stream of events to get the current state before adding something to it.
So you do, normally, and it's surprisingly fast. Like you can pull back 100 records of events and run them through your aggregate, like literally in the blink of an eye. Like it's trivial. But if they are slow because maybe you have a really big aggregate that has thousands of events and it takes a second, you could take snapshots in time of that aggregate to store it. So when a request comes in from the aggregate, you will first check your snapshots table for that ID, grab the latest one, do so as that, and then just play the events that are newer. So maybe every 100 events you take a snapshot, and then you're only ever playing up to 100 events, whatever your system can handle or
Since the last snapshot.
since last snapshot. So maybe take snapshots every 100, and then you're only playing at most 100 events.
Or nothing else. Well, Brad's saying you're not okay, yeah, it says.
Cool. Yeah, that's what's really neat. You now, the fact that your writes can scale and your reads can scale independently, you can spend a lot more money on your reads if that's where all your resources are needed, and that's what's causing a bottleneck, and still just have one service for your writes. If you do need to split it apart, there's ways of doing it. Have different command handlers handle like the different services. They just publish events. So there's ways of splitting it up there. Quite nice.
So you talked a little bit about versioning, event versioning. For aggregate, if you do need to handle new versions on your aggregates, how would you handle that? Like an updated field, you change the schema somehow?
It depends how much it changes, I guess. If it's drastic, it might actually be a new aggregate. Since I have to change mine, what I'm probably going to do is take snapshots of their current state of all my aggregates before I change them, so I never have to worry about replaying those old events with the old state of the aggregate. I can just take its current state and work from there. So now I can change what the structure of that thing is. I'm curious, like I haven't tried it. You could probably change them, and as long as they can handle the same events and get to the same results, you might be able to just modify it. That would be a little bit riskier. I would probably not do that as a first resort. I haven't had to do it yet, so I can't answer definitively.
So Mike's got a question.
About time.
So he says, without using a service bus, how do you handle fault tolerance and stuff? Like if your events aren't persisted and haven't been processed, what would happen? Would you lose that data?
So because I'm doing everything synchronously and the client is actually waiting all the way through until the read model's persisted, if it fails, it's going to bubble all the way back up to my client right now.
And to tell them they need to.
And tell them there was an error and
Right.
try again. Probably call me. If you had an actual message bus and it wasn't synchronous like my system is, that's where you would want to probably raise events that are your errors so that something can handle them and alert people or take some other sort of action. If your remodels don't get written, and I had that problem at one time because I had a locking issue, because I had too many people using it at once and they were all trying to write to the same thing that was deserializing, serializing. So I just made sure only one of those can happen at a time. What was I answering? Oh. Yes. So you can just regenerate them. If they're wrong, that's actually usually the first thing I try is I hit regenerate all, and also I go, oh good, it's fixed. It must have just been, something didn't save properly. Now that I fixed that locking bug, that's probably not going to happen again where I have these issues. So yeah, like your remodels being wrong is amazingly not a bad thing because they're very easy to fix. It's more important that the events get out and get saved. But if they weren't generated, how do you handle it when a normal application can't save properly? You throw up an exception, you alert somebody, you log it.
He's not asking you anything else. In depth.
Cool. You can ask me whenever. Anybody else? Thank you all for letting me talk at you.
So this might